Hey guys, this is the first lesson of Unit 7, our probability unit. We are going to start with Venn diagrams. Miss Snow conducted a survey of her homeroom class. She asked students what math course and science course they were taking this semester. So looking at our Venn diagram, the information is already filled out for us, and step 1 is asking us to figure out information about this Venn diagram. So one thing we can see is if we add up all those numbers, we have 29 students. We can also see that 14 plus 4 is 18, so 18 students are taking Algebra 2. If we add 4 plus 5, we know 9 students are in chemistry. If we look at the data, 6 students are in neither class. And we can see that 4 are in both. Okay, there's also more information you can see from this Venn diagram. You can see that 14 are only in Algebra 2. You can see that 5 are only in chemistry. But those are like the 5 things that I see right off the bat. Okay, so now actually using this information. So important things, we have 29 total kids. So that's what our data is going to be out of every time it's asking us for probability. So number 2, if a student selected at random from the classroom, what is the probability that the student is taking Algebra 2 in chemistry? So we have 4 taking both out of 29 total kids. So if we type that in the calculator, we get 0.138. If I told you my probability of picking a kid who has chemistry and Algebra 2 is 0.138, that doesn't really make sense, right? So we're going to multiply that by 100 and say we have a 13.8% chance of picking a kid who are in both classes. Okay, so it makes more sense if you turn your probabilities into percentages. A student selected at random, the student is not taking either of the courses. So we have 6 that aren't in either course. That gives me a 0.207 or a 20.7%. Okay, so we want to typically go to one decimal after, a percentage was one decimal. Find the probability that we have Algebra 2 or chemistry. So when you're finding probability of something with an or, so let's say A or B, that is equal to the probability of A plus probability of B minus the probability of A and B, so probability of both, okay? So when I'm looking back down here, I have the probability of A, so they're in Algebra 2, there's 18. Okay, and I'm going to add that to the probability of chemistry, which is 9 out of 29. And then I'm going to just subtract the kids who are in both classes. Okay, so 18 plus 9 minus 4 is 23 out of 29, which is 79.3%. Okay, and then we have a given statement. So we have the probability of a student taking chemistry given that the student is not taking Algebra 2. So out of all the kids not taking Algebra 2 is what we're looking at. So we have 11 kids not taking Algebra 2. And then now we want to see who's taking chemistry. So I have 5 out of those 11 kids. So if you're looking up here, I have 11 kids who are not in Algebra 2 at all. So that's going to go on the bottom. And then it's telling me I'm looking for how many of those kids are in chemistry. And that goes on top. Okay, so when I simplify that probability, I get 45.5% chance of picking one of those kids. And that makes sense because it's only talking about the ones not in Algebra 2. Okay, next question. Students surveyed, there are 758, people surveyed at this tennis match. 421 are males. I'm gonna actually write this different. I'm gonna actually break this down by each bullet point. So if I have 758 who are males, I want to go ahead and find my females. So if I subtract off how many males from the original number, I get 337 females. Okay, then it says 256 have a two-handed backswing. So that's total, males and females. 76 of the people with a two-handed backswing are females. So I'm going to find how many of those backswings are males. And it'd be 80 males with a two-handed backswing. Okay, and so now we can kind of start building our Venn diagram. So you can make a Venn diagram without a box on the outside, or you can have one with a box. It doesn't matter. I kind of should move it away from the page number. There we go. Okay. So I'm going to label this side as males and this side as two-handed backswing. So I have that didn't work. Okay, I'm going to need that 3 in a minute, so we'll just go with it. I have 421 males total. I have 80 of them who also have a two-handed backswing. So I need to say 421 minus 80 to get 341 here. Okay, then my total people with two-handed backswing was 256. I've already used the 80. I had 176 who are females, so they cannot be males also. And then I have 161 females who don't have a two-handed backswing. So that's how you would fill in your Venn diagram. Okay, the questions for this Venn diagram are on the next page, which is kind of inconvenient, but you can separate your pages if you need to. And we're going to look at the probabilities now. So what's the probability that a person selected is a male? So we had a total of 421 males out of 758 people. So that gives us 55.5% chance of picking a male. Probably the person randomly selected is a female, so same thing, but with the females. Probably most of you are thinking, couldn't you just take 100 and subtract off 55.5? Yes, you could, but if you messed that up originally, then you would mess up the next question. So you probably need to set up the fraction in order to get your answer correct. Was probability that a person selected randomly from the group has a two-handed backswing? So I'm going to take my total of two-handed backswings out of my total of people. And once again, I'm just typing these into my calculator as a division problem. So 256 divided by 758, and then I multiply it by 100 to get my percent. What's probability that a person selected randomly is a male or has a two-handed backswing? So once again, with or, you have to do add and then subtract. So I have 421. So total males plus my total two-handed backswings minus the males who have a two-handed backswing. And that gives us 78.8% of picking either a male or somebody with a two-handed backswing. Probably the person selected does not have a two-handed backswing, given that they are male. So you have to figure out how many males you have total. So we already did that, 421, that's a given. And then how many people didn't have a two-handed backswing would be the rest of the males that are listed. And so you have an 81% chance of picking one of those males. Okay, Miss Bradbury surveyed 110 of her Algebra 2 students to figure out who liked Chick-fil-A, McDonald's, and Wendy's. Probability that a student only likes Chick-fil-A. So I'm going to look at 22 out of 110. Where did I get 110? It tells us she surveyed 110 students. So that is going to give me 0.2 or 20%. We have McDonald's and Wendy's, so we're going to look at the middle of those two. And so I have and we're going to look here because they still like McDonald's and Wendy's. So I have 17 out of 110 to give me 15.5%. How many students do not like fast food? We're just assuming that those 17 people who are not included do not like fast food at all. We already found that decimal. Then we have students that like McDonald's or Wendy's. So we're going to figure out all of McDonald's, all of Wendy's, and then subtract off the ones who like both. So for all of Wendy's, I'm going to add all of these. Okay, and that gives me a number. I gotta do that really fast. 16 plus 8 plus 9 plus 12. 45. Okay, and then we have all of McDonald's, which are these ones. And that's 43. So now I'm going to go down here and I'm going to say I have 45 out of 110 plus 43 out of 110 minus 17 that like both. That gives me 71 out of 110, which is 64.5%. Then we're going to do the same thing with Chick-fil-A or McDonald's. So I'm going to add up. We already know McDonald's is 43. Then I'm going to add up Chick-fil-A's. and I get 62. So I have 62 out of 110 plus 43 out of 110. And then now we have to subtract off who like both. So that would be 24. And that gives us 81 out of 110, which is 73.6%. Probability the student likes Chick-fil-A given that they like Wendy's. So we know that 45 kids like Wendy's. How many like both Chick-fil-A and Wendy's? So we are going to look right here to get 25. And that gives us 55.6%. Okay, if you have any questions, you can reach out to your teacher. And remember, you can always pause or rewind the video. Thank you.